Welcome back to another great section of this wonderful tutorial class. Today I'm super excited to receive you guys back to class, and it's an honor to see you guys once again. Now, thank you for believing in us, and thank you for following us up, and pray that as you watch this class, may your understanding increase. Please don't fail to abide by the classroom, because you know that if you distract yourself, you are not going to gain much from the class. So please ensure you avoid distraction by any means. Try your best to avoid distractions and ensure you focus. That is very important. Also, don't skip any part of this video. Don't skip any part of the video. Ensure you watch this video from the beginning to the end. From the beginning to the what? To the what? The end. And as you do that, you will be blessed. So, what we have for today, we're having, because differentiation. That's what we are looking at. Differentiation. Now, differentiation is a topic in the mathematics branch that is called calculus. Now, calculus is just a branch of mathematics that has to do with, that deals mainly on the instantaneous rates of change, which we call differential calculus or differentiation calculus, and also has to do with calculus that is trying to define calculus. Calculus also has to do with or also deal with the summation of an infinitely many particles, in which after you have summed that infinite particles that are much, you will now sum it or generate it for a whole. I tell you that calculus is merely defined under differentiation and integration. Differentiation and integration. Differentiation has to do with something like rate of change, how something change related to another thing. While integration has to do with the summation of something like a little part in a whole. Then after that, you now generate it for that whole. Now we use integration calculus also when it is. Now integration calculus has two parts. We have one called definite integration and indefinite integration. Now the definite integration, we use it to find the area of under the curve. We will look at that later. This class is going to be very sweet. All you have to do is just to follow us. Just to follow us. We sum of the parts, sum of the whole part we are having. That will give you the area of that part you are seeing there. So we'll get there, don't worry. Now let's look at differentiation. Now, what is the meaning of differentiation? Differentiation is the art of finding the derivative of a function. We are finding the derivative of a function. We call that differentiation. Now, how do we find the derivative of a function? That is why we are here. Now, a function have different forms. We have different types of functions. Now, function is not just one. That's something you should know in this course. Now, one problem students do encounter under differential calculus is that they cannot differentiate one function from the other. Remember, we were told that differentiation has to do with finding the derivative of what? Of a function. Now, what is the meaning of function? I define a function. Now, function is just a subject can be said to be a function of a variable if a direct change in the variable will lead to a change in the subject. Now, we have different types of functions. We have different types of what? Function. Now, we have what we call polynomial function. Polynomial function. That is the first one we have. Then, we have what we call trigonometric function. Trigonometric function. Write them down. Write them down. It's very important. Then, what we call exponential function. We have implicit functions. We have implicit functions. Then we have parametric functions. Parametric functions. Please take note of those functions that I'm calling out, because we are going to be treating them one after the other. Now, if you now combine all these functions that I'm calling, now before I even we have what we call inverse trig functions. Inverse trig functions. Inverse trig functions. What we call hyperbolic functions. We call hyperbolic functions. They also have inverse hyperbolic functions. You have inverse, hyperbolic functions, etc. Now, if you now combine one of these two or more functions together, if you now combine two, like combine two polynomial functions, combine two implicit functions or more, or combine a polynomial and a trig functions together, then we will have other functions like product functions. We have something like product function. We have what we call quotient functions. Then we have what we call function of a function or a composite function. There's what we call a composite function. Now, what about a composite function? A composite function is a type of function that is formed from two or more functions that cannot be separated from each other. That's what composite. Composite means something that is not just one. A body that is composed of different parts, but they cannot be separated. When you cannot separate them, we call them composite, or something like a function of a what? Of a function. Function of a function. Now let me give you an example. Look at something. Now, polynomial function can be this one. Let's say 5x plus 3. This is a polynomial function. This is a polynomial function. Then, trig function is something like this. Sine, cos, these are just abbreviations for sine, cosine, and so on. Now, if I combine this and this together, I will form what is called a composite function. Now, we can say we have sine s, cos x. If I combine this together, in which I will not be able to sometimes separate them. Look, I can combine them in two ways. Look at the two ways. Look at the two ways. If I combine them like this, I can have sine x 5x plus 3. I can combine them this way. I can also combine them this way. Look at another way to combine them. Sine 5x plus 3. Can you see those two combinations? Now, these are two functions. These and this. Polynomial trig combined together. That is, we have this, having this and this. Now, this one now, in this case now, if I separate these two functions, they will still exist. If I separate these two functions now, I will have sine s, I will have 5s plus 3. Yes, they are still functions. But if I separate these two, I will have sine. Sine cannot work alone except there's an angle with it, which is what is in this front. We must have sine of something, sine of a variable or sine of an angle. So if there is nothing here, this will not become a defined function or a definite function. So if I separate these two now, you cannot differentiate sine only. There must be something with it. So these two cannot be separated from each other. If you separate them, one side will die. So that's why this one that cannot be separated from the other is called composite function or function of a function. That's what we call this one. We call this one function of a function. But this one you can separate. Which you see have sine s, you see have 5x plus 3. This one is called product function. It's called what? Product function. Now, if you want to differentiate all these functions, we have what we call standard differentiation techniques that we follow. We call standard what? Differentiation techniques. Then we have what we call chain rule. Now, chain rule is the rule used if you want to differentiate a function of a function. Something like this. A composite function can be differentiated using chain rule. Then we have what we call product rule. These are not differentiation techniques. Product rule. Now, product rule is used if you want to differentiate a product function like this. When we have two functions multiplying each other, and we want to differentiate it, we use product rule. Then we have quotient rule. Quotient rule is when you have two functions dividing each other. We use that's our quotient function. If you want to differentiate the quotient function, you use quotient rule. Then we have implicit differentiation. For differentiating implicit functions, we have ways of differentiating parametric functions and so on. But today, we are not doing a product rule, we are not doing quotient rule, we are not doing a parametric function, we are just doing introduction to differentiation. So we are going to start from how to differentiate a polynomial function. That's where we start from. how to differentiate polynomial function. So you have to you have to bear with me. Let's take a table down. Let's take a table down. It's very important to take this table down. Polynomial function. First person we have to do it down. Polynomial functions. First polynomial function. Now, write down this table. Let's say we have y to be a function of x. If you differentiate this y with respect to x, what are we going to have? This is y as a function of x. Y is a function of x. Then, if I now dy over dx means if I now differentiate this y with respect to this function, what am I going to have? So let's see what we're going to be having. Now, if this y is equals to a something like a number times s raised to power n. If I differentiate this, I'm going to have the power times the coefficient, which is n times a, s raised to power, then you remove one from the power. That's how to differentiate something like this. You use this power to multiply the coefficient, and you remove one from the power. Then, what if I have just a times x, in which the power is 1? For example, what I'm going to have? We are going to have just that a, which is the coefficient. Just the a, which is the coefficient. Now, this a and a can be any number. Take note. A section from 0. Even though it is 0 set, the thing will still be, will still work. Will still work. Still give us a good answer. Then, what about if I'm not just having x? If I want to differentiate s with respect to x, both this and this are the same. You have 1. I say differentiate a with respect to a to be 1. Differentiate b with respect to b to be 1. Then what about if I have a in the sense that this a does have this x? And y is a function of a, x, not a function of a. If I differentiate this one, what will it become? Since y is a function of x and not a function of a, then this will become a constant. Because this is not a variable now, it will become a constant. Why is a function of x? There's no x here. It's a constant number. And if you differentiate a constant, it will be 0. Since there's no s here. So, what about if I have s raised to power n? Still the same thing. Follow this. We have n times s raised to power n minus 1. Take note of this. Okay, I'll just be solving. Okay, let's take example 1. Just like this, example 1. Let's say we have y is equals to a s raised to power, let's say 3s raised to power 2. What will be dy over dx for this? And let's have from there. I'll just be showing you how to solve. Maybe I'll combine everything now. Next. Then, differentiate this, I told you, use the power to multiply the coefficient. Power is 2. So I have the coefficient, which is 3. Then remove 1 from the power. Then remove 1 from the power. So I'll give you 2 times 3 is 6. Then 2 minus 1, 1. If it is 1, you give it like that. 6x. That'll be the answer. Simple as that. Now, number 2. Let's say we have y to be equal to, so 3x cubed plus 4x squared plus 2x plus 4. What will be the y over dx? What will be the y over dx? Now, dy over dx will be equal to use this to multiply, use the power to multiply the coefficient. We are going to have 3 times 3, then 3 minus 1 plus the same thing, power to multiply coefficient. 2 times 4 s2 minus 1 plus 2x. Remember, if I have as, in which the power is 1, the answer will become a. So if I have 2s now, the power becomes what? If I differentiate it, the answer becomes 2. Because this power is just, the power of this s is just 1. This one is just like as. You do now, a is 2. If I differentiate as, the answer will be a. If I differentiate 9s, the answer will be 9. 20s, 20, with respect to x, so you take note of that. Then, plus, if I differentiate 4, this one don't have x. Remember, if I differentiate anything that don't have that x, like I'm differentiating related to, the answer will be 0. This one differentiating related to x. S is the variable here. So this one don't have the s, that will be 0. So this one becomes 9s squared plus 8s plus 2. Answer. Because 3 times 3, 9. 3 minus 1, 2. 2 times 4, 8. 2 minus 1, 1. Then 2 here, and 0. You're going to put it as 0. That becomes the answer. So we are going to look at some other good examples now. Then we'll call it a day. Please remember that this is for polynomial function only. We have for trig, We have for function with function, product function, and so on. But this one is just for polynomial function. Alright, let's take a look at these questions now before we go. And the first one I'm having here is if y is equal to 3 plus 2s plus 4s squared plus s cubed, what will be the y over dx? Remember, the over dx means differentiate y with respect to x. That's the meaning. So what is that? This one will have x 0, differentiate that. This one will be 2s, that will be 2. Remember, if I differentiate as, that's what will be a. Differentiate this one will multiply this 2 times 4, then 2 minus 1 plus 3 times x. Remember, the 3 times x, then 3 minus 1. So that will give us 2 plus 8x plus 3s squared. That's what I'm going to have. So now you leave it this way, or you can just rearrange it. So you bring ascending power of x, or something like something like this one is same as ascending power now. Let's take it to descending power. We have 3s squared plus, we now have plus 8x, we now have plus 2. That's why I do this way. This and this are correct. 3s squared plus 8s plus 2. Then, let's look at this one. This is another question. If y is equals to 1 minus x plus s squared plus s cubed plus s4, what is the y over ds? So, I know you can do this one now. You can do this. So, let me just tell you the answer. I know you have already done this. If you are following that, you can do this and now. So, if you differentiate this one now, there's no s here. That will be 0. Differentiate this one. Remember, if I differentiate x, with respect to s, that's how we 1. So that will be 1. Okay, s with respect to s, that's how we 1. So there's no power. And just power is just 1. Differentiate 2s, I'm having 2 times x, 2 minus 1. And this one will be 3 times x, 3 minus 1. This one will be 4 times s, 4 minus 1. So if you do that, I'm going to have minus 1 plus 2x. Okay, minus 1. Okay, that is minus 1. Plus 2x, 2 minus 1 is 1. Okay, that is 1. And plus 3s squared plus 4s cubed. Because 4 minus 1 is 4 and 3. So you can leave it this way, but you also rearrange in the ascending power of s. That will be 4s cubed plus 3. This one being the descending power of s now. 4 and 3s squared and plus 2x. And minus 1. It's not descending. So you get to 0. That is 4s cubed plus 3s squared plus 2x minus 1. So that's why I have the answer this way. The next, we have this. What will be the answer to this question? The question is, if y is equals to summation of n combination r of s per r, that arrows start from 0 to n, what will be the divide over ds? This one is just something like a polynomial function, put in form of a notation. You use notation to enclose everything together. So what I'm going to do, if I want to solve this one now, this one is a sigma notation. So it's not the function of anything. This symbol is a sigma notation. And this sigma notation is already in our channel. Take note of that. So if you just leave this alone, then if you go to this now, this n combination arrow. N combination arrow is a constant value. You can have 4 combination, 3, give a constant value. So that's just also a function. Then we have x here. Remember, we are differentiating y related to x. So this is s is per arrow. So if you differentiate that now, we are going to have something like this. So the only thing functioning here, everything here, something you're having here, this is a constant value. So it's just like this s, this is the coefficient, and this is s is per arrow. So what you're going to do, you're going to use this arrow to multiply these coefficients and remove 1 from the arrow. Remember, what we do? Our a here now, the a in this place now is n combination arrow, arrow start from 0 to n. So everything here is the a, this one is a, then s is per 1 r. So our a here now is this, our s is this, our arrow is this. Remember, if you want to do this, the answer will be what? This times this, use power to multiply the coefficient, then you remove 1 from the power. Remember, that's how to do it. So if I want to solve that problem now, I will just come, just something like this, to say, I will use this power now to multiply this coefficient. That will be, I might just bring the power here, or bring it to this xf. Anywhere I like, I can put it here, I can put it here, I can put it here. So far it's multiplied, there's no problem. So I will just write it out. I will start from 0 to n. of n combination. I'll bring the arrow here. Arrow times s is for arrow minus 1. You can also say arrow times everything. Still correct. So I'll just bring my own here. So that'll be the answer. That's all. So what you just use this arrow to multiply everything and remove 1 from the r. That'll be the answer to that. Now look at the answer to this last one. This one is if y is equals to arrow start from 0 to n. When you sum together arrow factorial w arrow plus 1 divided by arrow plus 1. What will be the answer to that? So let me clean this place so I can solve that one and explain it very well. Remember in that question now, check what are we related to? If I find the y over the w, there's no ds here. You say, this one don't have s, then you are going to something like go. So let's go. The y over the w will now be equal to the y over the w will be equal to. Now, what is the power of the first thing you note? What's the power of this? Look at this arrow plus 1. That's a constant number because the variable here is the w. This one is a constant number. So this summation arrow factorial over this arrow plus 1 is the coefficient. So what we are going to do now, we use this power to multiply this coefficient and we remove 1 from the power. For example, now this everything we have here and this one is the a. That is not just this over this. It's not the a. S is power n is not arrow plus 1. So what you do, you use this power since there's no w in this denominator. I think if we have w in this denominator now, we use a quotient rule. It will not become a quotient function. A function divided by another function. But this one is not a function because our variable is w. W is not in the denominator. So it's still a polynomial function. So what we don't do, we use this power to multiply everything here, then we remove 1 from the power. That's how to differentiate the polynomial function. So we are going to use arrow plus 1, multiply everything. Just arrow start from 0 to n, arrow factorial, then w arrow plus 1, then we remove 1 from the power. Then remember everything is over what? Arrow plus 1. So this one can cancel this. It's possible. Then what is 1 minus 1? That will be 0. So that gives us summation. Arrow start from 0 to n of arrow factorial over what? That is w is for r. This minus this will be 0. So this will be the final answer. This we cancel. You see, this one is even shorter than the question. So that's how we rule here. That's how we rule in this place. So let me give you a question. What about if I have y to be equal to a squared plus b cubed plus c 4 plus 9? What will be dy? What will become dy over the x for this question? What will become dy over the x for this question? The y over the x will become, check this one. Is there s here? No. That will be 0. Check this one. Is there s here? No. 0. Check is there s there? No. 0. Check is there s there? No. 0. The y over the x will be 0 because there's no x in the function. So everything here are constant. They are what? Constant. Please ensure you don't. But if I say what is the y over the a, you mention only the a, others will be constant. If I say what is the y over the b, you mention only the b, others will be constant. If I say what is the y over the c, you mention only the c, others will be constant. Please take note of that. This is how we roll under polynomial functions. Here's our channel. Please ensure you turn on our notification bell. In case we release any video, you'll be the first person to see it. So, God bless you all. See you guys in our next class. In case there's anything you don't understand there, you can watch the video over and over again. You are free to watch it as many times you like. The more you watch it, the more you get the understanding. And if you watch it, if you over and again, you don't get it, you can drop a question in our comment section. So, we are going to try our best to ensure that we serve you guys better. God bless you all. See you guys in our next class. Thank you. Thank you.